To academic, how to graph polynomial functions. All right, so go ahead. You got those notes I just gave you. Go ahead and start copying this stuff, okay? Start copying that down. I need to know 3 things, okay? And I'll explain this verbally. All right? So the last lesson, right, we talked about how to graph a quadratic equation, right? It looks like the U. Looks like a parabola. It's a parabola. All right? What's the difference between a quadratic equation and a polynomial equation? It's kind of a trick question. Yeah, so a quadratic equation is a polynomial. It's a special type of polynomial equation. A quadratic equation is a special type of polynomial equation. What makes a quadratic equation special? I said this like 4 times. What's the degree of a quadratic equation? 2. 2. No higher than 2. And a polynomial equation can have any degree, right? So a quadratic equation is just a special type. So we talked about graphing quadratics. Today we're going to talk about graphing polynomials in general, okay? How to graph general, like any polynomial, okay? You just need to know 3 things. You need to know the end behavior of the graph. So let me draw some coordinate axes. The end behavior of a graph is what the graph does as x goes to the right forever and as x goes to the left forever, okay? All right. So what's going to happen? So for example, if your polynomial has even degree and its lead coefficient is positive, as x goes to the left forever, your graph's going to go up forever, and as x goes to the right forever, your graph's going to go up forever. Okay, so that's end behavior, okay? What's going to happen if we make our lead coefficient, if we still have an even degree polynomial, what's going to happen if we make our lead coefficient negative? What do you think is going to happen? It's going to be like that. So as x goes to the left forever, our graph goes down forever. As x goes to the right forever, our graph goes down forever. Okay? All right, and similarly, if our degree is odd, if the degree of our polynomial is odd, the end behavior is opposite. Okay? So if the lead coefficient is positive, we're going to go down forever as our graph goes to the left. As our graph goes to the right, it goes up forever. All right? Then what do you think happens if we make the lead coefficient negative? It'll just switch. Okay. The polynomial dance. All right? At prom. Do the polynomial dance. OMG, bro. OMG. I know it's no. I won't do it. I won't go there. It's only February. All right. So you need to know about the end behavior. You also need to know the roots of your polynomial. Okay? What's a root? What do I mean by what's a root of a polynomial? We've said this. We've talked about it. What's a root of a polynomial? Anyone tell me what a root is? What?
Does it involve the x?
Yeah, it does. So when you take a polynomial and set the whole thing equal to 0 and solve for x, that solution is a root. Okay? All right, the roots are going to tell you where your graph touches the x-axis. Those are going to be your x-intercepts, okay? Notice I used the word touch, right? I used the word touch because what? Number 3 here, right? There's 2 different ways that the graph can touch the x-axis, right? What do you think those are? It can like go straight through it, or it can bounce off of it, right? Right? Like when you skip a stone on a lake, right? It can either like bounce off or it can go sink straight through. Okay? Kind of a weird analogy, but yeah. So let's get that written down. That's basically everything you need to know. Now the rest of the class will just be examples. Anyone know where my Apple Pencil went? right here. Okay, so let's practice this. Okay, so you look at your chart here, okay? What's my lead coefficient for this polynomial? 4, and it's 4 what? Positive or negative? Pos, right? What's my degree? 7 an even or odd number? Odd, okay? So odd positive. So let's go to the chart. Here we go. Look at the odd positive line. What's my end behavior going to be? What does it say? I'm just going to stand here until someone says it.
Why does X lose?
Yeah, so, sorry. I was rise right. We're going to rise right and fall left. Okay, so let's draw a picture of that. I'm going to draw coordinate axes, okay? So my graph is going to go up on the right and down on the left. Okay? That's what I mean by rise right and fall left. Alright, what about this next one? What's my lead coefficient on the next one? Is that negative or positive? So that's negative. What's my degree?
6.
It's even, right? So what's my end behavior going to be? On my chart, negative, even, negative. Fall right, fall left. So I'm going to go down on the left and down on the right. Okay? What about this next one here? What's my lead coefficient? Trick question. It's negative 1. So what's my highest? So your lead coefficient is not necessarily the number they wrote first. It's the number next to the highest degree term. What's my highest degree term there? 5, yeah. So my degree is 5, and the number next to 5 is negative 1, right? So negative 1 is a negative number, okay? And then the degree is 5. Is 5 odd or even? Thank you. Odd. Negative, odd. Odd, negative. What's my end behavior? Fall right, rise left. Okay, so on the right, we're going to go down. On the left, we're going to go up. Okay? Feeling okay so far or no? Are we confused? We good? Good stuff. Alright, we probably think we have that chart filled out. This next part right here, this is the same thing, except instead of giving us a polynomial and writing down, gosh dang it, sorry, writing down what the end behavior is, they've given us 3 graphs. They've actually given us a picture of the end behavior, and we have to tell them what the degree and lead coefficient are, okay? So what's this graph doing? We're going down on the left, right, and then up on the right. So let's come up here, fall left, rise right, right here, fall left, rise right. What does it say? It says my degree is odd, and my lead coefficient is positive. So we have odd pos. Odd pos. Okay, this next one, what are we doing on the left?
Rising.
What are we doing on the right? Rising. Rise right, rise left. What's that? Rise right, rise left. Even pause. Even degree. Lead coefficient is positive. It's positive. Alright, and then what's that last one gonna be? Odd negative. Odd negative. Okay, we feel okay? Alright, so that's all about end behavior, right? That covers this first topic. We have to look at the degree, and we have to look at the lead coefficient, okay? Alright. to talk about zeros and their multiplicity. Okay, and then we're going to sketch the graph. There wasn't really not a lot of room, so I just scratched out those first two, and I wrote down some steps for graphing. So you can ignore those for now. Let's talk about finding the zeros. How do you find the zeros of a polynomial, or the roots? Those are the same thing. Zeros, roots, x-intercepts, those are all the same thing. How do we find them? We literally talked about that forever already.
Like you break the numbers down like 1 and 2, like 1 times 2, and then
For this one, yeah, so you're on the right track. We're trying to factor.
yeah.
Yeah, so you're going to set it equal to 0 and solve for x. Best way to do that here is to factor. What's my GCF? 2x to the squared. 2x squared. So that's x squared minus 2x. No, minus 4x, sorry. Plus 3. Okay, let's keep factoring. X minus 3, 1. Okay. Once I'm all factored like so, how do I solve for x? Set each factor equal to 0 and solve. So x equals 0, x equals 3, x equals 1. So those three numbers, those are my x-intercepts. Okay? So I have to write them as points. How do I write the x-intercept as a point if I know the value of x? I know Sheldon knows. Who else knows? Yeah, so the y-coordinate of an x-intercept is always 0. Please remember that. You know what? I'm just going to go make a scene. Guys, please remember the y-coordinate of an x-intercept is always 0. Okay? Your y-coordinate on your x-intercept is always 0. Okay? It's always 0. Y-coordinate on an x-intercept is always 0. Okay, thank you. Hopefully that'll save me some time grading the next test. All right, and then the x-coordinate is just whatever you solve for x. Okay. All right. So these are my three, what are called my zeros or my x-intercepts right here. Okay. Who knows where we get the multiplicity for each 0? What do I mean by that? How do we find out the multiplicity?
Is that the part where you use a calculator?
No. I'm on the right track. So let's look at this factor. The factor that gave us the solution x equals 0. What's the exponent on that? 2, right? What's 2, even or odd? So this 0 right here has even multiplicity. Has even multiplicity. Okay? What that means is the graph bounces off that 0. It bounces off that point. It does not go straight through it. It just bounces through it. Okay? What's technically the exponent on this factor that gave me x equals 3? 1, right? Is 1 an even or an odd number? Someone other than Sheldon? Odd, yeah. So this is going to have some odd multiplicity. So what do you think the graph's going to do there? It's going to cross, yeah. The graph crosses through that point. Okay. This one, exponent is also 1. 1 is still an odd number. Odd mult. The graph's going to cross to that guy right there. Okay? All right, so let's sketch a graph now. We have everything we need. Once we know the end behavior, and we know the zeros and the multiplicity of each 0, we have everything we need. So x, y, okay? First step here, plot your x-intercept. So I'm going to plot these 3 points I just found, okay? That's a good way to start. That's a good way to start. So 0, I'm going to do this in pink. 0, 0, 1, 0. I'm just doing a sketch. And 3, 0. So I just plot those 3 points. Okay, we know how to do that, hopefully. All right, what's my end? Oh, I forgot end behavior. I knew this was going fast. Sorry, what's my end behavior going to be here real quick? What's my lead coefficient? My lead coefficient is 2, right? Is that positive? What's my degree? 4, right? That's even. So I'm going to do what? Look at my chart. Even positive. Even positive. Rise right, rise left. Okay? So rise right and left. All right. Forgot about that step. I'm sorry. I apologize. Okay. So let's draw that in. So what arrows do I need to put here? So out of that left point, I'm going to draw an up arrow, and out of that right point, I'm going to draw an up arrow. Okay, I'm going to rise left and rise right. So I'm going to go those 2. Whichever 0 is on the left, whichever point is farthest to the left, you draw the end behavior on the left out of that. Same thing for the right. Okay. So I'm going to draw an up arrow out of both those points. Okay. And then what's my graph doing? Let's look at. What's my graph do when it touches 0, 0? Bounces right off it. Okay, does not cross through it. Okay, and then it's going to come back down. What's going to do when it gets to that second point? It's going to cross straight through. Then it's going to come back around to this third point, and it's going to cross straight through. Done. Okay, that's how you do these.
When is our quiz again?
Mrs. Hollis is doing hers tomorrow.
So that goes on Monday?
I haven't decided what I want to do. You guys want to do it tomorrow?
Who did we see on
I guess I won't do it tomorrow, out of the goodness of my heart. I haven't decided. Let me talk to Mrs. Hollis
What?
about what I want to do. It'll be Monday at the earliest. Okay. Let's go to the next one. So let's not make that same mistake. There's a bunch written over here. Let's do this one right here. Okay. So let's talk about the end behavior. Let's not forget this time. I like to do it first. What's my end behavior going to be? So we need to look at what 2 things? My LC, right? What's my LC? What's my lead coefficient? 9, right? 9 is a positive number, so my lead coefficient is pos. Posy. I don't know. I'm trying to make math a cool thing. My degree is what? 3. Is 3 an odd or even number? Odd. So odd positive. Odd pos. Odd positive. Rise right, fall left. So rise right. Fall left. Okay, there you go. There you have it. Alright. There you have it. And then what do I need now? Yeah, factors. Yeah, so I need to set it equal to 0 and solve for x. I'm going to do that by factoring. A lot of 9x, x squared minus 9. That's a difference of squares. It's DOS. Difference of squares, not disk operating system. Okay. Alright, so what are my 3 zeros? X equals 0, x equals negative 3, x equals positive 3. What are those as points, though? I need them as points. 0, 0, negative 3, 0, 3, 0. Yep. There you go. There you have it. Alright. And then what's the multiplicity? How do I find the multiplicity again? For each of those points? Yeah, so look at these 3 factors that gave me my 3 zeros, right? What's the exponent on all of them? 1. one is an odd number. So they all have odd multiplicity. Odd mult. Odd mult. Odd mult. Okay? What does my graph do when I touch zeros of odd multiplicity?
It bounces.
Crosses. Think, guys, here's a good mnemonic device, right?
Well,
Think,
the last one.
here's a really good, the last one it bounced, right? Even multiplicity bounces, right? It bounced off of x equals 0, right? Bounce.
So why does it not bounce?
Because the multiplicity is odd. This one, it does not bounce this time because my exponent, look at the factor that gave me x equals 0. The exponent on that is 1. That's an odd number. Let's look up here. The factor that gave me x equals 0 had an exponent of 2. That's even. That's where my multiplicity comes from. Look at the exponent on that factor. Okay? So yeah, mnemonic device, right? Think odd, cross, even, bounce, right? Right? I know you can people usually associate even numbers with bouncing and odd numbers with crossing, right? So just think that, right? Right? If you go to a trampoline park, they'll probably have an even number of trampolines, right? No? The mnemonic device was me just trying to act funny. It's all good. It's all good. Maybe you just might need to memorize that one. Sorry. Actually, I'm not sorry. Okay. So what do I need to do? What's my first step? Let me draw some coordinate axes. It's probably a good first step. There we go. Some coordinate axes. What should I do first? Yeah, let's plot my 3 zeros here, okay? 0, 0, negative 3, 0, and 3, 0. All right, what do I want to draw now? The second step. My end behavior. Drawing your end behavior. So what's my end behavior? Look at the purple. Actually, the whole thing's purple, sorry. Look at this purple. What am I doing? Rise right. So I need to draw an up arrow out of which point? 3, 0. I need to draw a down arrow out of which point? Yeah, there you go. And then we just finish by drawing the multiplicity. They all have what kind of multiplicity? So the graph, yeah, cross. They all cross through. So the graph's going to go straight through that first point. Come back down, it's going to go straight through that second point. Come back up, go straight through the third point. Done. All right, I'm done. I can go play Fortnite with my friends, watch TikTok, go cake bake. If a girl has a birthday, I always ask, I'm like, hey, what are you doing for your birthday? It's always like cake bake. Like, such a popular place, it sounds like. I've never been there, but I want to try it. They have pretty good cake. Pretty solid. Like take my sister or something. So it looks more socially acceptable. Anyway, right here, let's do number 9. Numero 9. Okay, so what's nice about this problem? It's already factored, yes, that is nice. So the 0 is going to be pretty straightforward. The 0 is going to be fairly straightforward. Oh gosh. But is anyone a little confused on how to get the end behavior? What's the lead coefficient here? That? Yeah, the lead coefficient is going to be that number that's out the front here. So, okay, a better way of explaining this, the lead coefficient, it's that -4, and there's technically a 1 here. Everywhere you see an x, right, take the number in front of it, multiply them all together, that's your lead coefficient. So your LC is going to be -4, which is even. Okay? How do I get the degree of this polynomial? So we're not in standard form, right? Instead of all of our terms being added together like this one, or subtracted together, right? They're all added together here. When I'm in factored form, right? Everything's multiplied together. How do I know what the highest degree is? You can multiply it out. That would take forever though. You can add the multiplicities, so just add all the exponents there on your factors. Okay, so what's the degree of this one going to be? 4, which is even. So we didn't see that. Okay, so this factor, what's that? Yeah, we do. So that I'm finding the degree. So the exponent here is 2. The exponent on this factor is 1. The exponent on that third factor is 1. 2 plus 1 equals 4. That's an even number. Okay. So multiply these front coefficients for your lead coefficient. Add the exponents for your degree. Okay. So even, negative 4 is negative. Sorry, I don't. No, so the lead coefficient's negative. Sorry, I don't know why I wrote even. So negative, even, negative. What's my end behavior? Fall right, fall left. Okay, and then we're going to come back here. Now I can get my zeros, right? That's the easy part. That's the easy part. That's the easy part here. What are my zeros going to be? Are my roots? X equals 0, x equals 2, and x equals negative 5, right? How do I write those as points? Yeah, there you go. And what's the multiplicity on all of them going to be? So let's look at x equals 0. Let's look at the factor that gave me x equals 0. What's its exponent? So what's my multiplicity? Even. So it's going to bounce or cross? It's going to bounce. Remember, like the trampoline park has an even number of trampolines. I don't know what else to say. Sorry. I'm bad at mnemonic devices. Multiplicity on the other two is what? Odd, yeah, it's just 1. Odd mul. Got some odd mul. Cross. Cross. Okay. We have everything. We have my end behavior, I have my zeros, and I have my multiplicity. Okay? So what should I plot first? My zeros. Yeah, so 0, 0, negative 5, 0, 2, 0. All right, what do I want to sketch on now? Look at the orange. Fall right, fall left. So where do I draw my arrows? Down on the both endpoints. Okay? And then, am I going to cross through that first pink point or bounce? Let's look. Negative 5 comma 0. Ross. Yeah, be careful. Got him. Come back. What do I do here? Bound. Now I bounce. And then what do I do on this last one? Cross. All right. There you go. That's it. All right. You guys okay with that? All right, let's do another one. Do another one. What's a really hard one we can do? Yes. I kind of like number 11. I think I'm a big fan of number 11. So let's just cross out 12. We're going to graph it next to 12. All right, so let's figure out that end behavior. end behavior? Okay, what's my lead coefficient going to be here? How do I find that? So there's a 1 in front of this x, a 1 in front of this x, and there's a -4 in front of everything. So it's going to be -4 times 1 times 1. -4, that's negative. Okay. Am I losing you guys on the lead coefficient stuff or no? You just multiply all the front numbers together. How do I get the degree? I add what? You add all the exponents. So this is a 1 and a 5, so that's 6. Wherever there's an x, you look at the exponent that's outside of it, and you add them. 1 plus 5 is 6. So degree is even, lead coefficient is negative. What's my end behavior going to be? Look at the chart. Look at the chart. Fall right, fall left, right? Yeah, fall right, fall left. Even, negative. Cool. Oh, I accidentally made an ellipse instead of a line. Whoops. Hopefully we'll get to conic sections in this class. Who wants to learn about ellipses? No? Okay. Don't worry. Mrs. Hollis and I are doing our best. We're going as fast as we can so we can make sure there's time for that at the end of the year. Okay, so now what do I get? What do I get now? I got my end behavior taken care of. What do I need to find now? I need to find all the zeros, right? In addition to their multiplicity. Okay? So -4, does -4 give me any zeros? Just -4 equals 0? No, that's contradiction. Okay? What about this next guy? X equals 2. What's that as a point? 2, 0, yes. What about this next guy? Yes. What's the multiplicity on 2, 0? Odd, yeah, because it's 1. The exponent is 1, so we have odd molt. We do what when we have odd molt? Cross. Okay, and my multiplicity here on this on this -7, 0 is what? Odd. Right, because 5 is an odd number. So we're going to cross. We have everything we need to graph. Everything we need. Can I start by doing what? Plot. Plot your zeros. 2, 0, -7, 0. And we're just doing a rough sketch here. Okay, so plot your 2 zeros, plot your 2 x-intercepts. They're the same thing. Roots, zeros, x-intercepts, all the same. Okay, I'm going to fall right and fall left. Fall right and fall left. Okay, so where do I draw my end behavior arrows? Both down, coming out of those points. These are different color. It's a pretty color. Gray. All right, what do I do when so they're both, I just lost my train of thought, sorry. What's the graph going to do through that first point there? Cross. What does it do to the second point? Cross. Yeah. There you go. Okay. That's good. That's enough examples, I feel like. Let's stop there and work on your homework for tomorrow. Let's look at the homework, though. I don't want you guys to do everything. What's that? No, keep them. Let's do 1, 3, 5, 7, and 9, and then the back page. So cross off 2, 4, 6, 8, and 10. All right, and then I'll post that video to YouTube real quick.